Good morning folks, and welcome back to another update on the electric glider here on campus at UWE in Bristol. I'm really sorry for not having gotten back to you earlier. It was really busy to actually get the whole purchasing gear, but I'd like to release the information to you now that we actually got the glider on campus. So in addition to the first video block and the airframe check, we're actually that next step further, and UWE committed to the fact of actually, committing to this project and giving green lights to it. And I can't even wait to show you even more footage and pictures what we're actually doing. So we started actually doing our research and we rebuilt the nose, we took a mold of it. There was a lot of administrative stuff going on as well, which needed doing. So these are a couple of reasons why I actually didn't get back to you earlier in that sense. So today is a bit of a different setup. We're actually testing a couple new systems on the copters we're running, so I thought I might as well just talk to you through the new technology we got on campus. So we're just at the minute busy with getting another ARC, so an annual review certificate done on the glider. So basically it's MOT for it. Once we obtain this on the upcoming Friday, we are then legally ready to go to start our work. So yeah, I'm just really interested of getting a lot more information out to you guys, and I hope you stay tuned. See you soon.
So, as mentioned earlier, the time between the release of the first vlog and this one was spent on the legal side of the project. This includes liaising with the Civil Aviation Authority, Royal Aeronautical Society, European Aviation Safety Agency, Light Aircraft Association, as well as the British Gliding Association, the manufacturer of the glider we hold, and I could really continue on this one. A considerable amount of emails, phone calls, meetings and a couple of conferences later, I am happy to state that we are experiencing an uplifting support from all the mentioned organizations and would like to express my sincere thanks to all the people involved so far. Please let me now introduce you to the scope of the project.
So, to sum up all the e-conditions talking we did today, I want to sum that up in a project we actually started about a year ago here in this place, when I participated in last year's General Aviation meeting and sort of was flying without an airframe around me when I walked out, because I was utterly delighted about the conditions in general and the decisions that have been made to deregulate and make it easier for UK companies and institutions and researchers in general. So, having started this project about 1 year ago, I was looking into buying an airframe for our university, and then together with our students and involving our students as a learning and experience type of project to change this airframe from a glider to an electric glider. So at the end of the day, it's a little bit more than a student experience project. It's sort of, I personally see it as looking into CO2 neutral flight, and there's been projects out there which did the same thing before. There's a Czech Republic company, there's a front electric sustainer. So it's not something we come up entirely new with, it's been done before. But as I said before, the basic idea behind this topic is to give our students the ability and the chance to do something applicable, to apply the knowledge in a project. So I'll tend to speak about it as a formerly student in the automotive sector. I don't know who of you is familiar with that, but it's basically a project run throughout universities in all Europe, where students come together and they form a team within their studies, and they build a race car and race it once a year. Now this is quite far ahead thinking, but now the e-conditions actually do allow us to look into doing something similar together with our students and get the experience out and share that knowledge for them to do something applicable as well, and in the end hopefully test flight under the e-conditions. Now I'm aware of the fact that a couple of people, a couple of voices are raised beforehand saying, oh, what are we going to do with our airframes after the e-conditions? Now, we're of course quite interested in keeping them flying, but from sort of looking into the a little bit unknown, we are very delighted about having the opportunity in the first place, and also as a university would like to cooperate with the CAA and all the aviation institutions and make regulations for the future. So we're very open, very approachable. I like that project to be of as much sort of fundament as we can possibly get out of it for the students and for future aviation as well. So, and thanks Howard for that very insightful electric actuation speech before. I think there's a couple of technologies which now are actually sort of recognizable or doable with the conditions. So we hope as a university to do that one step forward and actually launch with the conditions. So thank you very much for setting that purpose up and that proposal up. We are very delighted about having it. Thank you.
Whilst you're looking at a time-lapse presentation of the aircraft, I would like to take the chance to introduce you to the idea of these vlogs I'm doing. The chance to work on a project like this was just given about 1 year ago with the release of the conditions. In future vlogs, I would like to invite you on our journey, converting this glider into an electric, self-launchable technology carrier, applying highly efficient propulsion components and systems. You will experience success and failure throughout the research and witness milestones and setbacks as we pass them. With this project, I would like to raise awareness of the change in thinking we have to undertake in order to make aviation cleaner and contribute to the conservation of this wonderful planet we call a home. I'm looking forward to welcoming you on board. Make sure you subscribe and stay tuned. For the curious ones, I added a little taster of the next vlog's topics.
What we're looking into today is we're trying to make a composite testing specimen. What you see here is a carbon fiber specimen to go on a tensile testing machine, and we've got material, it's called E-glass, 200 grams per square meter, but we want to make sure that the specifications we found for it, or coming from the manual or data sheet that comes with it, are actually true. Before we want specimen of the width of 25 mil and a length of 100. So we're going to make 3 different layups, 5 plies, 7 plies and 9 plies, so overall we need 21 of those. Alright folks, so we're back with a couple of superbly cut specimen raws by Alex. So we've got a staple of 9, 7 and 5 layers of glass. Obviously that's not solid yet. So the next step would be, what we want to be doing is we weigh the glass in order to know its precise weight, and then the mixture or the ratio between glass and mixed resin is 60-40. So 60% of the final product's weight will be made from the glass cloth itself and 40% from the resin. So that's the ratio we're going after. The resin itself is mixed at a ratio of 100 to 29. So we got 100 grams, as an example, of resin and 29 grams of hardener. And however much you finally work out making, you always want to keep that ratio, because that defines sort of the properties of the final product, whether it's too brittle, too ductile, or whether it cures in the given time as well.